All right, and finally, one of the last prerequisite ideas we're going to talk about is the bend. Now, the bend is remarkably similar to a break, except instead of hitting a 0 point and rotating our hand, we're going to do a float and rotate our hand. And by hand, I mean center of rotation. So a float would just be, if here's my orbit, I'm going to do a linear extension. So I'm going to extend my hand up in a line. Boink. In that moment, while it's going up or while it's coming down, it's just kind of not adding to the orbit. It's just floating and extending, right? During that float, I have, as slow as I can do this float, is as much time as I have to rotate my plane, right? So the pendulum thing, new plane. But instead of waiting for a 0 point, while I extend up, I rotate my hand, and then I give a little flick of my wrist to give momentum to carry on in the same direction. So here would be the pendulum break for the plane change, right? But to do a bend, I'm going to do it while it's moving up. So on the front of the orbit, while it's moving up, I will move my hand into the new plane. While it's moving up, I will move my hand into the new plane. I can do it this side too. Up, I'll move it towards you. Or again, up, now I'm out front. Right, so this is bending every up. So my poi will make 360-degree orbit and bend around essentially the same point in space, an isolated point, right? So if I do 360 degrees of orbit between each bend, you have an isolated bend point. So you'll notice I was doing that horizontally, right? So it's the same thing, except for my extension now, instead of extending up and rotating around the axis of extension, my center of rotation will rotate around the head on that axis of extension, of that float axis, right? Just like your 0 point. Boom. But it'll also be moving with the float. So we float it this way. The same thing happens, right? It's floating horizontally, so I can rotate my hand, give it a flick, and end up horizontal. So I'm going to float it this way and bend around this top part of the orbit. Boom. Now, I can do the same thing. The edge of the orbit over here, float it that way, bend along the edge of the orbit. You could do the top of the orbit going this way. I could do, that's with these bends, you have essentially a few variables that you can start compiling, right? So first of all, where in this orbit do I want to bend, right? Am I going to bend along this edge? Am I going to bend along this edge one direction or the other direction, right? So from here, I can get it to go this way, or I can get it to go this way, which results, this is a forward, you know, if I'm going to face that, now it's reverse. So I get two different results from the way I bend around that initial decided point. But now, what if we do it up here? So our initial bend point yields also two different horizontal directions. Now, what about the far side? Boom. Same shit. It gives us the two initial directions, but in reverse. We can get fucking anything. How about the horizontal on the bottom? Boom. Oh, look at that. Looking familiar, right? Horizontal on the bottom again. Boom. Oh, sorry. Horizontal on the bottom again. There, like that. Diagonal. See that? Boom. This diagonal. Back where we started, this diagonal. Back where we started, this diagonal, bending forward instead of towards me. Bending towards me, right? This bottom diagonal towards you. This bottom diagonal bending towards me. So in every one of those demonstrations, the last variable that I just kind of took for granted at being 90 was the degree of bend. So where I bend it, which direction I bend it, and how far I bend it. All of those variables combine to basically make it so that within two bends, you can change into any other orientation, any atomic orientation, any other vertical versus vertical, like any other orientation of your poised planes that you want. Within two bends, They don't have to be the same bend in each hand, but within 2 bends, you can get to any other. It's pretty mind-boggling because of all the variables in each bend, you know. So that's cool. The bending correlates a lot with the breaks because that's how we're going to get from our parallel planes into these atomic orientations. When I'm saying atomic orientation, what I mean is 2 planes that are perpendicular to each other. So right now I'm just demonstrating on the axis of bend. But once you do that, you just bring your hands together. Now you're in an atom, you know, like that. So this is just getting into the different atoms or, you know, different planes using bends. So we got one more prereq. We touched on it a little bit with that diagonal bend thing. That's going to be diagonal planes. This one shouldn't take long.